Hello students, welcome back to our channel. Today we will solve a problem that has appeared in JEE 2024 in advance just 2 days back, and we will solve this problem using some technique and using graphs. First, students, you should solve this problem, at least try yourself, and then you can see this video so that you can understand what is the process. Okay, first you should try. Now look at this problem. So a function is given from R to R such that fx equal to x square sin pi by x square when x not is equal to 0 and at x equal to 0 function is 0. So this is a pairwise function. Okay, and then which of the following statement is true? Fx equal to 0 has infinitely many possible solutions in the interval 1 by 10 to the power 10 to infinity. Fx has no solution in this interval 1 by pi to infinity. Fx has finite solutions in the interval 0, 1 by 10 to the power 10, and fx has more than 25 solutions between 1 by pi square to 1 by pi. So basically, students, we have to find the number of solution of fx equal to 0. That is, we have to find the number of possible cut on x-axis through this graph. Okay, so first we will see some theory of calculus and we will solve this problem using graphs. Okay, so let's start. So first of all, look, this is a pairwise function. Fx is given in such a form: x square sine pi by x square when x not is equal to 0 and 0 when x is equal to 0. First, we look whether this function is continuous or not, because there is a break at the point x equal to 0. Okay, so to understand its nature, it is very important to see whether graph is connected or disconnected. That is, whether the function is continuous or not continuous, because this is a break in the point x equal to 0. Okay, so we will first check in this thing. So to use this thing, to check these things, we have to use a theorem called sandwich theorem. Okay, sandwich theorem, which states that if fx is a function in such a way, fx is a function in such a way that fx lies between gx and hx, and when we let x tends to a certain limit a, okay, and if gx and hx converges to a, then we can say that without any calculation, we can say that these fx will also, sorry, if when x tends to a, if gx and hx converges to suppose l, then without any calculation, we can say that this function which lies in the middle of gx and hx will also converges to l. Okay, we will use this sandwich theorem to understand the nature of this function at, when x tends to 0. Now, students, as we know that the range of sine x is lies between -1 to +1. Whatever it may be x, it may be x square, it may be pi by x, or something else. Sine theta always lies between -1 to +1. Okay, so we can start from here. So sine pi by x square always lies between -1 to +1. Okay. Now x is function defined from R to R. So x is a real number, and square of a real number is always a positive real number. Okay. So we can multiply this inequality with x square, and these inequalities will remain same. There will be no change. Okay, because x square is a positive term. So we multiplied this in equation with x square. So this becomes sine pi by x square, and this lesser equals to x square. So now look at these things. Just compare with these inequations with Sandwich theorem. So this is our desired fx, and this is gx, and this is hx. And we are checking this continuity at the point x equal to 0. So we have to take limit x tends to 0. Okay. Now if we take limit x tends to 0, then we can see that these minus x square will also converges to 0, and plus x square will also converges to 0. So using Sandwich theorem, we can say that the mid function x square minus 1 by sin pi by x square will also converges to 0. And this is our fx. Okay. So limit x tends to 0 sine pi by x square into this is equal to 0. Okay. Which is equal to f of 0, because at x equal to 0 the functional value is 0. So f is continuous at x equal to 0. So students, using these structures, we already derived that fx is a function which is continuous. Okay. And it will continuous throughout this whole R. Okay. Because the only breakpoint is 0, and we have already shown that function is continuous at x equal to 0. So the graph will be connected graph. Okay. Now we are going to sketch its graph. Okay. And to draw the graph of this function, we will see another theory that, so we are going to use another theory. Look, fx is x square sine pi by x square. If we take f of minus x, then it will remain same. Okay. So fx, so f is an even function. Since f is an even function, the graph will be symmetric about both side of y-axis. Okay, because this is an even function. Now we will draw the graph of fx. Okay. Now one thing, as we can see that at x equal to 1, and x equal to minus 1, and at x equal to 1 and x equal to minus 1, we have sine pi. So, and sine pi is 0. So when mod x equal to 1, fx will be 0. This is clear. Now see, when mod x less than 1, that is when x lies between minus 1 to plus 1, x lies between minus 1 to plus 1, then pi by x square will be greater than pi, because x square will be less than 1. Okay. Then therefore pi by x square will be greater than pi. So in that case, sine pi by x square may be positive or negative, because it may lie in second, third quadrant, or fourth quadrant, or first quadrant, or second quadrant, because sine pi by x square, pi by the value of pi by x square is greater than pi. Okay. And when mod x less than, strictly greater than 1, then pi by x square is strictly less than pi. So actually this is the theta. Okay. So then sine pi by x square is less than pi, sine theta must lie between either on first quadrant or on second quadrant. Okay. So when mod x greater than 1, that is when mod x greater than plus 1, or when x greater less than minus 1, then function will be always positive, because when x greater than 1 or x less than minus 1, pi by x square will always less than pi. And always less than pi means, friends, always less than pi means that sine theta will this theta must lie in either on first quadrant or on second quadrant, and we know that sine theta is positive in first quadrant and second quadrant. So when mod x greater than 1, this is very important, students, this part is very important to understand, this two part. Okay, this two part is very important to understand. When mod is greater than 1, then pi by x square is always less than pi, so sine theta will be positive. And when mod x less than 1, so pi by x square greater than pi means that theta may lie between in third quadrant or in fourth quadrant, or it will be cyclic, then it once again can come first quadrant or second quadrant. Okay, so it may be then positive sine theta or maybe negative. Okay, so now we will draw this graph. And one more thing is that, so it is clear that x equal to plus 1 and x equal to minus 1, this function will be 0 and then positive. So from plus 1, this we can say this graph will be like this. Okay, and since function is positive, and from minus 1, this function will be like this. Okay, now one more thing is that as x tends to 0, pi by x square tends to infinity. Okay, so sine theta will convert, so this function fx x square sine pi by x square will converges to 0, because we already know that at x tends to 0, x square sine pi by x square is 0. So as x tends to 0, this fx x square sine pi by x square will converges to 0. And since pi by x square tends to infinity, it will oscillate rapidly. It will oscillate rapidly, but as x tends to 0, since the function converges to 0, its frequency will be increases, but length of oscillation will be decreases simultaneously, because it converges to 0. Okay, so the graph will be look like this. As x tends to 0, the frequency will rapidly increase, but the oscillation will decrease. And as x increases, then, and since this is an even function, as a property of even function, the graph is always symmetric about y-axis. So the graph will be same as right side. Okay, so just is a mistake of uh, sketching, but it will be symmetric about both the sides. Okay, so what will be the correct option? So as we can see that as x tends to 0, the oscillation will increase. That is, it will move from positive to negative rapidly, but the length of the oscillation will decreases and it tends to 0. So genuinely we can see that between 0 to 1, yeah, there will be infinite number of cut. Not actually 0 to 1, we can take any point near about 0. There will be a number of infinite solutions. Okay, we can't predict the numbers, there will be infinite number of cut. Okay, now we will discuss all the options thoroughly. In option A, it is given that fx(0) has infinitely many solutions between in the interval 1 by 10 to the power 10 to infinity. Now look, if I fix a number 1 by 10 to the power 10 somewhere here, just right side of 0, we will have a number of cut that will be always finite, because after 1 we will have no solution. Okay, and in the interval 0 to 1 by 10 to the power 10, just left side, suppose this is 1 by 10 to the power 10, and in the left side of 1 by 10 to the power 10, as we can see that using sandwich theorem, x square sine pi by x square tends to 0. That means that since sine is a oscillatory function, it will oscillate, but as it tends to 0, the length of oscillation will decreases and it converges to 0, but the oscillation will remain. Okay, so there will be infinite number of solution between 0 to 1 by 10 to the power 10. Okay, and after 1 by 10 to the power 10 to 1, however it cut the x-axis, it will must be a finite number of times, because after 1 we cannot have any cut. Okay, so option A and B is not true, and option C is the set of solution fx equal to 0 in the intervals is finite. This is not true. So our true option is option D.